So in this video I'm going to be demonstrating my OpenGL GLSL shader code and also describing the math behind it. So we're going to start off with the diffuse, and we see here that we have our light in the scene and our object with our normals in green here. And when our light comes down and hits the normal, it creates an angle with it, and here we assume that it's an angle of 15, and when we use cosine we get a number between 0 and 1. With this angle we have 0.96, meaning that there's light hitting it, and we could see that it's evident because our light is hitting directly onto our normal. Here we have an angle of 105, and when we use cosine on it, it gives us a negative number, negative 0.25. That means that there's no light hitting that object. Of course, we can't have a negative number for brightness, so we just assume that it's 0. In our code here, we have light and our normal. And using the dot product of the two essentially gives us the same answer as if we were to cosine the two directions. And with the max function, we ensure that we don't return a 0 or a negative number when our dot is negative. So that makes sure that it's between 0 and 1, not 1 and negative whatever. And then we add that to our diffuse with n.l, and then we return it to our frag color to be used as an additive value to the URGB. With our ambient, it is literally just a coefficient that we use to brighten up the scene so that it's not dark regardless. With our specular, just go back a bit, we have brightness and normals, but this time we have a camera in this scene, and the camera direction makes an angle with the normal, and when our light makes an angle with our normal, it's the same normal angle as with our reflection, and if it equals our camera angle, it should cancel out with the brightness angle, meaning that there's going to be shininess that our camera can see at that point. Whereas if our camera is not the same as our reflection angle, then we're not going to see the shininess that is reflected off of the brightness angle. In our specular code, we do the same thing as with diffuse with our normal and our light, but this time we calculate a view vector, which is our text coordinate minus our camera coordinate, and then we add the light and the view vectors to see if they cancel each other out. And then we use it as h with our dot product of nh. And then we do the same as diffuse, and we max that value. And then this time we use pow with shininess so that the user can define how shiny the material becomes, and return that value as specular light to be added to our frag color. With rim, it is essentially the same thing as diffuse, except we're trying to find the areas where it's the darkest. So we use 1 minus the max of the dot product, NV. And then we smooth it out with smooth step. And we return it as the rim to be added to our frag color. With a ramp texture, we load in a 1D texture that is 1 pixel high, which is a Y of 1, and however many pixels wide with X. And when we take our diffuse brightness, which is a float, and we compare it to our X, we find a new ramp brightness to be added to our frag color as our ramp. It's essentially the same thing with color grade, except we have 3 values that we compare instead of just 1. We compare our RGB to the XYZ coordinates of our LUT table, and then we take whatever is in that LUT table and we return it as our new RGB. Each coordinate has its own RGB values, so that means that we could convert our old to new. In our code here, we use texture, which samples whatever our old RGB values are. In this case, it's our diffuse plus rim times ambient plus specular. And we compare it to our sampler 3D that we loaded in as a uniform, and that becomes our new LUT color. And then we use that LUT color instead of our diffuse, rim, and ambient and specular in our frag color. So here we have our rendered hand, and if I toggle the ambient, we could see that we could change the brightness that is present in the scene already without the light. And with the specular, there's a shininess with the camera angle. As the light moves around, it changes. Then with our rim, if we move our camera so that the light is behind the object that is being displayed, we'll see that there is some brightness at the edges of the object. With diffuse ramp, we see that the brightness is segmented to be whatever our 1D sample texture is. And then with our color grade, there is the 3D texture that is sampled and compared and replaced. And that is it for this video. I hope I get a good mark, and thanks for watching.